Hello everyone and welcome to Physics Revolution. You might be thinking, where I was so long? Yeah, I had multiple reasons for not being present in YouTube, and I would like to make this channel much more simpler. I don't want to talk much and give more advices, but rather I would like right now to get into the task. And what is the task which I am here with? To make physics simple, right? No more editing. I'm just fed up of doing a lot of editing works, so I just want to put physics more in my videos. Now, as I told you, I'm here to make physics simple. The idea here is that I would like to discuss 9th, 10th, 11th, 12th physics. And not only that, here I am there to make some of the tough competitive examination physics look very simple. Yes, I'm going to make it look very simple. So today I'm going to start with some of the JEE advanced question. You all must have heard about JEE advanced question and their difficulty level, but there are few techniques, there are few concepts that you should be knowing before you can even make it very easy and simple for you. So let's begin with some of the questions. Now here let me screen share and let me bring you one of the question here. If you are a student of 11th or 12th, you will be able to relate it much more. Okay, so let me bring you to the question here, and if you see in the question, in this figure, let me come here. Yeah, in this figure, a ladder of mass m is shown leaning against a wall. It is in static equilibrium, making an angle theta with the horizontal floor. The coefficient of friction between the wall and the ladder is mu1. I hope you are able to see all those values, mu1. And the coefficient of friction between the ladder and the floor is mu2. The normal reaction of the wall on the ladder is n1, and the floor and the ladder is n2 if the ladder is about to slip. Okay, what is going to be the condition here? So now I shall begin in this way. Since I have friction, okay, I have mu1 and mu2, both are not equal to 0. Let me start with this condition, both are not equal to 0. That means there is some friction which is holding this in static equilibrium. It is holding it in the static equilibrium because it is clearly mentioned that it is in the static equilibrium. When I say static equilibrium, that means there is no net force acting on it, there is no net torque acting on it. You should know that static equilibrium means force, torque, both are going to be 0 in this case. So let's begin in this way. Mu1 is not equal to 0, mu2 is not equal to 0. That means I have some amount of friction. Now I know that because of this friction, because of this contact, there is going to be a normal force. You see here, the ladder is in contact in these two places. One is in the floor and other one is with the wall. One is with the floor and other one is with the wall. They both are in contact. Now the first basic force that I should bring there is normal. First of all, normal is already mentioned in the question, so first bring the normal. Normals are always perpendicular to the area of contact, the point of contact or the surface of contact. So here is my normal n1. This is the direction of n1. It is the normal due to the wall, and here is my n2. It is a normal, of course, due to the floor. I have my two normals here. Now, if you have studied the formula for friction, I know that the friction is equal to mu into normal. This is a formula that you study in class 11, or even in the lower grades you will be studying this formula. This is the frictional force. Now, what is the frictional force due to the wall? Now, if you see here, the frictional force due to the wall is F1. I would say it is due to the wall. Okay, so F1 is going to be equal to mu1 into n1, right? The formula is self-explanatory. There is no confusion in the formula. F1 is equal to mu1 into n1. Now, finding the magnitude is not just enough. I need to find out which direction does it go into. Yes, force has a magnitude and direction. I got my magnitude, but where is the direction? Because without the direction, this mechanical problem will not solve it. I would not say mechanical, this mechanics of this problem will not be solved. So I know that if the ladder is about to slip, if the ladder is about to slip, it is going to go down, it's going to fall down, right? So the friction should be always opposite to the movement. So my friction F1 is in this direction. I got my direction of F1. Next is F2, the friction due to the floor. It's going to be mu2 into n2. Simple. It's going to be mu2 into the n2. Now what is going to happen here? I have the magnitude. Where is my direction? Think carefully. If you think, you will understand that if the ladder is slipping, this portion of the ladder is coming down and this portion of the ladder is going this side. Common sense. Coming down, going this side. So the friction on the floor is going to be in this direction, opposing the motion. The name of friction itself, it is the force which opposes the motion, right? Now this is the direction of F2. I have mu1, I have n1, I have F1, I have m2's direction, I have F2's direction. Now there is one more force which is doing everything. It's the force of gravitation. And the force of gravitation, where should I draw it? It should be drawn on the center of the ladder. You know that this ladder is having length L, okay? The ladder is having length L, it's given, isn't it? The ladder is of mass M and length L is given, and the mg is going to act downwards. Mass into gravity is going to act downwards. Now I have got all the vectors which is required to solve this problem. Am I missing anything else in this? You can think. If you have studied vectors in 11th standard, you should know that all of my vectors are there. I have normal force, I have friction force for the wall and for the floor, and I also have mg, the weight of the ladder, acting downwards. Now when it is in equilibrium, now let's come to the equilibrium. It is mentioned for me that it is in the static equilibrium. Okay, it is in the static equilibrium. So since I'm dealing with forces, I should make sure that all the forces are balanced, right? I have forces here, right? N1, F1, mg, all are forces. Now if it is in static equilibrium, all the forces are balanced. All the forces are balanced. Now how would I do that? Okay, now let's talk about the direction. Let's talk about the direction. Now that means the forces acting in the opposite directions should have same magnitude. Forces acting in the opposite direction should have same magnitude. So my directions are up, down, left, right. Up, down, left, right. Let's look into left and right. So you see here, this side, can you see N1 is going towards my, what hand is this? Left. N1 is going to my left, right? So N1, and what is the force which is going to the right? If you see the diagram, it's only F2, and that is mu2 into N2. Left right balance is done. Now up down balance has to be done. Okay, now you see here F1 is acting upwards, N2 is acting upwards, and you see that mg is acting downwards. So downward force is equal to F1, that is mu1 N1 plus N2, mu1 N1 plus N2. Now what I'm going to do here, okay, now what I'm going to do here is that I'm going to substitute. Now once I get this equation, okay, you see, now let's come to the answers. Now you see in my answers I have mg by 2, mg, so that means I have to do something with mg. I have to do something with mg. What can it be done? To keep this mg here, the only possible substitution that I can make is this one. Here, n1 value I can put. So when I put the n1 value, mg is equal to mu1, mu2, n2 plus n2, right? Now you see n2 are here, I would take them as common. Mg equal to n2 1, okay, now you see here 1 plus mu1 into mu2. You just bring n2 here, and that's going to be mg divided by 1 plus mu1 into mu2, and you see here my answer is C. Is C here. Yes or no? So this is how I do my first question, right? This is how I get the answer for my first question. So I hope this thing has made sense to you. Now let us talk about the second question here. In an electric kettle, okay, a heater of an electric kettle is made up of a wire of length L and diameter D. It takes 4 minutes to raise the temperature of 0.5 kilo of water by 40 Kelvin. This heater is replaced by a new heater having 2 wires of same materials, okay, but each wire are having length L but diameter 2D. Now the ways these wires are connected in given in the options, how much time in minutes will it take to raise the temperature of the wire, temperature of the same amount of water by 40 Kelvin. So first understand the situation here, students. What you're having here is initially you are having a heater, and in that heater you have a wire of length L and diameter D, and using that particular wire you are heating it. It takes 4 minutes to raise the water of 0.5 kg by 40 Kelvin. Now there is a second heater, but in that second heater there are 2 wires. Now in that second heater you have to connect 2 wires either parallel or in series. It's your wish, either parallel or series, you have to connect it. Now they're asking you, if you connect it in the parallel, how much time will it take to raise the temperature to 40 Kelvin, If you are connecting in series, and how much time it is taking to raise the temperature by 40 Kelvin. So basically the question is, if series, how much time? If parallel, how much time? So in my option, series, parallel, both are given. So I should try with series first, then parallel next, and see if the answers are there in the options. Remember, this is a JEE question, so you might have to spend a little time in analyzing the stuff here. Okay, let us consider that this kettle, initially when this kettle had only single wire, the resistance of that wire did the heating. The resistance of that wire did the heating. So the heat developed, I know the formula of the heat developed by Joule's law of heating, that is H is equal to V square by R into time taken. Okay, V square by R into the time taken. Right? Now, of course, I know that the time taken in that situation, was 4 minutes. So I will keep it as V square by R into 4 minutes. Remember, I am keeping it in minutes. The time I am following is in minutes. Now, same amount of heat is required to raise the temperature to 40 Kelvin. I know that, right? Same amount of heat is required, then only the same mass will raise by 40 Kelvin. So now my idea is, I need to find out the combination and the time where same amount of heat is being produced. Okay, now I know that the resistance R initially which was used is resistivity into length divided by the diameter is given to me. So if it's diameter, it's going to be pi d square by 4, right? The cross sectional area is pi r square, but since it's diameter, it's d by 2, so there is going to be a 4 on top. This is my resistance of the actual first wire, which could heat in 4 minutes. But now the equipment is changed. Now first let us see what is the resistance of the new wire. Let's see what is the resistance of the new wire. The resistance of new wire, the length is same, the material is also same here. New material having to a same material. When I say same material, they mean that resistivity is same. Make sense? Resistivity is same. Good. Resistivity is same. Length is same. What is not same? The diameter is 2d. Diameter is 2d, students, so radius is d. So pi r square, pi d square. This is my new resistance, the resistance of the new wire. Have a look. Compare them. You compare them. You can compare it visually. You will understand one thing for sure, that is R dash is R by 4, isn't it? You will understand that visually, right? Now this is what is required. I know the relationship between the old resistance and the new resistance. New resistance is R dash. R dash is the resistance of the wire which is being used in the new material. It is being used in the new material. All right. Now here I have a relationship between the old wire and the new wire. The new wire is put in the new equipment, new heater. Okay, first what do? I put them in series. When I put them in series, my total resistance, okay, my total resistance RT, I would write, it's going to be R dash plus R dash, and that's going to be 2R, isn't it? It's going to be 2R. 2r dash, and 2r dash is nothing but r by 2. I substitute the value of r dash, it's going to be r by 2. When put in series, the total resistance in terms of the old resistance is r by 2. In terms of new resistance, it's 2r dash. When put in parallel, it's going to be r total is going to be r1 into r2 divided by r1 plus r2, and I would say that it is going to be r by 4, r into 4, so it's going to be r square by 16 divided by r1 plus r by 4 plus r by 2. It's going to be r by 4 plus r by 4 is r by 2, so r is going to get cancelled here, so it's going to be r by 8 at the final. Okay, r by 8 at the end. So when connected in series, it's r by 2. When connected in parallel, it's r by 8. Now you have a look here. What is my main goal? The main goal is how much time is required to get me this much of heat energy. And how much of heat energy it is? V square by 2. Now I would say that both the heater, they are working in the same voltage. Of course, if you buy a heater at home, one heater is not going to work in different voltage, another is not going to work in different voltage, because your home is having a voltage of 220 to 240 volt. So every equipment that are being made should only be 240 volts, so that it makes sense that all the home equipment should have same voltage. So V is going to be same in all the cases. Now, how much of heat has to be produced? V square by R into 4 heat has to be produced. Now let us see how much of time is taken for series. Time taken for series. How much time is going to be taken for series? It is going to be, so I would say in this way, V square by, what's the resistance? R by 2 into series time is equal to V square by R into 4. Oh no. Right. So V square by R by 2 into Ts. So I would say that this R into 2 is going to go on top, and these 2 and 4 are going to be cancelled. Then R and R are going to be cancelled. At the end, you are going to see Ts. The time taken in the series connection is going to be 2 minutes. Time taken in the series is going to be 2 minutes. So your option is B for series. On the same hand, I do for the parallel one. Okay, I know that for parallel, I got the resistance to be R by 8. I got the resistance to be R by 8. Now I would put V square by R by 8. T time for parallel is going to be equal to V square by R into 4. Right? Now when 8 goes on top, it's going to be 2 V square R and R is going to get cancelled, and TP, the time for parallel, is going to be half minute, which is going to be 0.5 minutes, and your option is D, 0.5 if the wires are parallel. Now you might be thinking why these has to answer. Yes, these questions, some of the JEE advanced questions also have to answer. So what is your trial here? What is your agenda here when you are solving advanced question is that you need to do hit and trial method sometimes. So in parallel and in series, in both the cases, I have my answers. So So for today, it's only 2 questions for JEE in Advanced. I hope you have understood the way how these questions need to be done. Not only that, I will be sharing a lot of methods on how to make these things easy, because the questions that we have seen right now is advanced questions. And the more and more practice you do, you're going to see that these questions are going to become more and more easy for you, right? So with that, I will end today's video. We will see in the next video with more and more concepts from different classes, not only 12th or JEE NEET. We will see from many 9th grade and 10th grade some of the difficult questions we will be doing, and you should be able to see how even a difficult concept in physics looks very easy. So with that, I'm signing off. We'll see you in the next video. Adios.